This is just a video recording of our answer key for the last test in mechanics on projectile motion. So let's get started. So you've got a rock that is launched from a volcano with an initial velocity. So we have an angle 35 degrees. So we need our initial velocity in the j direction. This is using sine, initial velocity, in the I direction, which uses cosine. Now, determining the maximum height for the rock, I'm just going to use v final squared equals v initial squared plus 2as. We know that 0 is the final velocity at max height, so 0 squared equals 14.3 squared plus 2 times negative 9.8 times s, and that gives us a height of 10.4 meters. Now that is 10.4 meters above its starting point, which is here, and if you add the 20 to that, you do get 30.4 for that. All right, continue. Determine the velocity vector at the maximum height. Well, I'm going to leave that in ij notation there. So our final velocity at maximum height is 0 in the y direction or j direction. Therefore, my answer is velocity is 20.5 meters per second I. There's only the x direction velocity at max height. So 20.5 meters per second I plus 0 meters per second j. Determine the total time the rock is in the air. Okay, so that means it must fall down 20 meters. So its displacement is 20 meters when it hits the ground. So therefore, I have 0 equals 14.3 t minus 4.9 t squared plus an initial height of 20 meters. And then I will use my solver on my functions of my calculator to get 3.95 seconds for my answer. And what's the horizontal range for the rock? That means how far did it go in the x direction while it's in the air. Since I know 3.95 seconds now is the time it was in the air, I just take my x direction velocity, or I velocity, 20.5 times 3.95 seconds to get 81 meters. Determine the velocity vector just before the rock hits the ground. Now, in this case, it will have I velocity and j velocity, but I need to calculate my j velocity. So I know its beginning velocity is 4.3 meters per second. So I'm going to use v final equals v initial plus at, so 14.3 minus 9.8, which is the gravity acceleration, times the total time it's in the air, 3.95. That gives me a final velocity in the y direction of negative 24.4 meters per second. Then my velocity vector in ij notation would be 20.5 meters per second in the I, because that's a constant velocity in the x direction the whole time, minus my 24.4 meters per second in j that I just found. And that's our first question. Next question here. We have a cannonball fired with an initial horizontal velocity, and it just barely makes it over a tree that is 12 meters away. So here it is at 12 meters away in the x direction. It has a height of 8 meters. So we want to figure out what the launch velocity. Now this is a x direction velocity only, so there is no y direction initially. So then I'm going to say s is equal to v1t plus 1f(at) squared. That simplifies to how far did it fall on the 12 meters going this way? Well, it's at 14. It's now at a height of 8 meters. Therefore, it fell at negative 6 meters. So I say negative 6 is negative 4.9 t squared. I took half of 9.8 to get that. And my t is 1.1 meters. Now, it traveled 12 meters in the x direction while it fell at negative 6 meters there. So I'm going to say 12 equals vi times 1.11 seconds. I'm just using s equals vt. And solving for v, I get 10.8 meters per second. Now, that is a horizontal launch this way. Determine the total time. Okay, the ball is in the air. Well, then I know it's going to fall an entire 14 meters. So I'm just going to increase my negative 6 to negative 14 equals minus 4.9 t squared. Solving for t, I get 1.69 seconds. Next question. What's the horizontal range for the cannonball? Well, again, I'm just going to use s equals vt in the x direction. I know I've got 1.69 seconds. 10.8 meters per second is my x direction velocity, multiplied by 1.69. That gives me 18.3 meters. Next question. If the cannonball was launched at an angle now 30 degrees above the horizontal, so that means it's going to get launched this way. From the top, would it make it over the tree? Assume the same launch speed. So now I have to break things into ij. So my initial j velocity would be 10.8 sine 30, which is 5.4 meters per second. My initial I is 10.8 cosine 30, or 9.35. So what I do is I find the time it takes the ball to reach the tree. And I know I've got 12 meters to get there. So 12 equals 9.35 t. The time it takes for the cannonball to get where the tree is located is 1.28 seconds. Now I just need to figure out how much the cannonball has fallen from 14 meters. So S is equal to 5.4 times 1.28 minus, again, half of our acceleration is 4.9 times 1.28 meters, or seconds squared. The displacement has fallen on the way over to the tree is a negative 1.12 meters. Okay, that means we are falling from 14, so we're definitely above, okay, the height of the tree at that point. Reminder to you that 8 meters is how high the tree is. When the cannonball goes up and then reaches the tree, we're definitely above 8 meters because we've only fallen a little bit more than 1 meter down, which is like 12 and some change above there. So, and again, it's going to go up like that, and then on the way down. So it's now higher than it was before, so it will make it over the tree. Okay, our final question. This one is a little vector addition relative motion thing. You've got a ship that's moving in the direction to the right. Okay, it's going 15.6 meters per second this way. You have a plane on the deck moving 8 meters per second in this direction here. We'll call that, this is east, and this, of course, would be north and west. So I break this vector into x and y's, or i's and j's. So vi is going to be negative 8 cosine 55. I'm going to add that to the 15.6 going this way, because I've got an x direction velocity this way because of this airplane. But the ship is moving that way. So then my VI is going to be 11.0 meters per second. Okay. The J going across this way is not affected at all by the x direction velocity of this ship. So I'm taking 8 sine 55 for that, and I'm getting 6.55. So the velocity of our plane relative to a stationary plane is 11.0 meters per second I plus 6.55 meters per second j. So now it says, determine the time it takes for the airplane to cross the width of the aircraft carrier. Well, I'm going to say, well, I know the width of the aircraft carrier is 76.8 meters. The plane is moving this way. I'm going to use the y direction velocity only. So 76.8 equals 6.55. There's my vj t. Now these are all constant velocities, no acceleration going on here. The time it takes for the airplane to go across this ship is 11.7 seconds. Now it's asking, how far is the plane moving in the x direction during this time? Well, then I'm going to take that resultant velocity in the x direction, because remember, it's trying to move north or west, but the ship is moving east. So I'm just going to take 11.0 times 11.7, that's 129 meters. And that, of course, is the x direction going to the east. Okay. And the last question says, determine the velocity vector of the airplane relative to a stationary point. We've already done that, and I'm just going to write that in ij notation. That's 11.0 meters per second I plus 6.55 meters per second j. And that was our test.